I am Sudarshan and I am a student of MTech PED from VIT University, and today I am here to discuss a little bit about Introduction to Frequency Converters. In this lecture we will understand what a frequency converter is, what its basic function is, what its main functions are, what its auxiliary functions or secondary functions are, why a frequency converter is necessary, what's the control circuit of a frequency converter, and how frequency converter works. So this will be the entire introduction to the topic of frequency converters. Now what is a frequency converter? It's a very simple device. A frequency converter converts the supply mains AC, that is your three-phase AC or single-phase AC depending on which application you are using. It converts a single-phase AC to variable voltage and variable frequency output. Now this variable term is very important because it has two components. One is variable voltage, the other is variable frequency. So both frequency and voltage are variable in this case. Okay. Now this frequency converter, which is also known as FC for frequency converter, has multiple other names. In industry they are calling it in different ways. It's also called as a variable frequency drive, popularly known as VFD, or adjustable frequency drive AFD, or variable speed drive or variable adjustable speed drive. So it can be called in any of these names, either VFD or AFD, VSD or ASD, but overall what it means, it is a frequency converter. Okay, so frequency converter converts supply mains to variable voltage, variable frequency output. So this is the basic function of a frequency converter. Now let's understand why this frequency converter FC is required. What is the need of a frequency converter? Can't we function without that? Now let's consider a scenario where we have a motor that runs an application. Now this application may be a fan or a pump or anything. So basically there is an output of the application which is your the required process. Now the input to the motor is voltage and voltage signal of a constant frequency. Because of this, the motor will rotate at constant speed. This speed will depend on the frequency here. Therefore, if this frequency is constant, the speed will be constant, application runs at a constant speed. What if in a scenario when such an application is running, we want to change the speed? We will have to change the frequency of the supply, which is not acceptable. We cannot expect to change the frequency of the supply mains, that is not possible. So there should be a mechanism to do an operation that gives variable frequency here input to the motor, so that output is not constant speed but it is a variable speed. This is why a frequency converter is employed. So in the new system, what is done is a frequency converter block is applied and the input voltage with a constant frequency is being applied to the entire system. So this will be the new system, which is a basically controlled system. Now as I told you, a frequency converter converts supply mains of constant voltage and frequency to output voltage of variable value with variable frequency. So this value here is a variable voltage and a variable frequency. This value can be controlled. Ideally speaking, we have infinitely variable voltage and infinitely variable frequency. This is a very ideal scenario. But by adjusting the FC parameters, we can get a very high range of variable voltage and a very high range of variable frequency. And so depending on the parameters that we have given in this FC, the parameters that I will be telling later, we can get some speed with which the motor runs. Now, if I need a change in the application speed, all I have to do is change some parameters in FC so that this frequency changes, this speed changes, this speed changes. So therefore, this becomes a control system where we don't have to deal with input voltage changes, we don't have to deal with changing input frequency, but we should only deal with the change in parameters of the frequency converter. And since frequency converter is a device, it is very simple to change the parameters with no problems. So this entire scenario is why a frequency converter is very necessary and is widely used in every industry. Now let us see what are the inputs given to the this frequency converter. The frequency converter, as I showed before, is connected to a motor. So the input to the frequency converter will be the nameplate details of the motor. And what nameplate details are necessary, we will see now. So input to FC from motor nameplate will be, first will be the voltage rating, say 400 volt or 230 volt or whatever is the voltage that the system is running at, and then you have your current rating, this current rating depends on the voltage rating, say 1.7 amperes at 400 volt, or it may be for 230 volt, say 2.8 amperes. So depending on what voltage your motor is running, your current will be decided, and then you have a power rating. In watts, and then you have the speed rating in RPM, and finally we have the frequency, say 50 Hertz or 60 Hertz if it is in US, where 60 Hertz is used. Now remember that all these inputs are taken from the motor nameplate. These are not given in data sheet or anything of the frequency converter, but it is taken from the motor nameplate. Now after all these inputs are given, we have to know what all functions a frequency converter does. As I told you, there are some main functions and there are some auxiliary functions or optional functions. So based on that, we will see what are the functions of a frequency converter. So at first we have the main function, and then we have the optional functions. And these functions are listed with respect to a practical frequency converter module. Okay, so theoretically there might be many other functions, but practically these are the, what I'm going to list will be the main functions of a frequency converter. First of all, it has a start stop function, which can either start or stop the motor. That is one function. The next function, which is a very basic function, very basic need of FC, was change speed, changing of speed. Now when speed has to change, it is not acceptable to change the speed instantaneously from value say n1 to value n2. This is not acceptable. Why this is not acceptable is, let's consider a scenario where we have say a conveyor belt which is moving like this. Now here is a motor connected to it which is driving the conveyor belt. Now let's say there are some parcels moving here to some system. If motor is running at a speed n1 and instantaneously we change the speed of the motor here, it is possible and most likely scenario that one of these one or more parcels will tumble down. Therefore, the entire process gets disrupted. This is not acceptable, and therefore this instantaneous change of frequency is not acceptable. This is not only applicable here, but in case of say hoist, where we have cranes that lift equipment from bottom and take it to another level. Even in such cases, if there is a sudden change of speed allowed like this, it is possible that there is a breakage of any component. So because of this, this entire scenario of sudden change of speed is not acceptable. Therefore, we have something called as ramping. And therefore, ramping can occur in two ways. It can occur in acceleration function or a deceleration function. Meaning, you are either increasing the speed or decreasing the speed. In either ways, it should work as a ramp and not as a sudden change. It should work as a ramp and not as a step change. So this is one of the functions. Along with this, even though we said theoretically infinite variation is possible, there are some limits, and these limits occur due to limitations in the components, limitations in their values possible, their tolerances, and many other functionalities. And along with this, there is another option called the maintained speed. So these are the main functions of a frequency converter. We have a start-stop to start or stop the motor. We have a change speed that changes the motor speed, and that change should occur as a ramp and not as a sudden change. Then we have certain limits, upper and lower limit, that FC can work in, and then there is a function called maintain speed. Now along with this, there are some optional functions. The optional functions include braking, and then we have maintain load, and we have another function called changing direction. These are some of the optional functions in a practical frequency converter. Now these functions, all functions can be disabled, and only some functions that are necessary can always be considered. Now we understood about the functions, we understood about the necessity of a frequency converter. Now we will get a brief idea of how a frequency converter or a VFD works. Now there are four main components in a frequency converter module. We have a rectifier, and rectifier is fed from AC. AC means the output of the rectifier will be pulsating DC, that is given to an intermediate circuit. And the output of the intermediate circuit is given to an inverter, and the output of the inverter will be AC. So with this, there is one more unit, which is your control unit. This control unit controls the rectifier, the intermediate circuit, and the inverter circuit. This control unit has firing angle controls for the rectifier, firing angle controls for the inverters, and also intermediate circuit controls. So this component are very simple. First thing, there is input AC, it rectifies to pulsating DC, and here the output is DC and it inverts into AC. Now we'll see what this intermediate circuit does. I told you that this is a pulsating DC. Our first aim should be to make sure that this value is an almost constant value. So this intermediate circuit has two functions. One is smoothing the DC voltage and then providing energy storage for an inverter. We know that for a basic inverter, we have a DC storage. So this storage element is also provided by the intermediate circuit via a capacitor, and there is a smoothing reactor, wave smoothing reactors. So therefore, the intermediate circuit will consist of a circuit something like this. This is going to a inverter, and this is coming from your rectifier. So what these inductors do, they have two functions. One is smoothen the DC, and this capacitor serves as a fixed stiff source for inverter. So we are getting a pulsating DC here that is smoothened by the intermediate circuit whose circuit looks something like this, and then that is being fed to the capacitor, and the capacitor will hold the charge and it will act as a fixed stiff DC voltage for the inverter circuit. So all this, the entire circuit is being controlled by the control unit. So this is the basic control arrangement, and this control arrangement can be done in two ways. One is a remote control or local control. So if there is a VFD installed in an industry, it can be controlled remotely using a remote controller, or it can be controlled locally by using the panels that are present on the control panel. So this is the entire operation of VFD. It is a very simple operation, very simple concept. However, the circuit involves three major components and one control component. Now the last part of this will be the application in closed loop. So as we spoke about the motor before, we have a frequency converter which is given input from a let's say AC supply. Now the output of a frequency converter should be given to your process whose output is fed back to the load using a programmable logic controller. Programmable logic controller is a basic control system. Okay, so now what this entire system does is, by depending on what output is present and what output we require, that is the reference that we give. Let's say we want some particular speed here, so that will be given as a reference value here. So depending on the output, a comparison will be done, an error signal will be generated, and the control system in the frequency converter will control the inverter and the rectifier, and the output will change based on the requirement, and that output is given to the process. Now this process is your, say, motor in a pump. So it's a motor connected to a pump. So this voltage will be given to the motor that will drive the pump at the required output. Now again, if there is a change of output required, that will be given to the reference. The output will be sensed. A control system will it will change the values that are necessary, give variable voltage, and again the entire motor pump combination will run at the required speed. So this is all about introduction to frequency converters. Thank you.